Hello everyone, today we're going to look at some complex number problems for IB Maths higher level. These are AA problems and yeah, we're just going to go and do them, I think. I need to plug my stuff in, hang on. Alright, so we've got this problem. It says find three distinct roots of the equation z cubed plus 64 equals 0, giving your answers in modulus argument form. Okay, so this is an interesting setup. Z cubed we're basically taught, I'm going to make this a bit thicker. Z cubed is basically equal to negative 64. Just because that's how we rearrange the equation. If I think about this, not in terms of roots yet, just as a complex number, I can think about what this should look like on an Argand diagram, where we have our imaginary components vertically and our real axis horizontally. If we're at negative 64, that suggests that we are starting at the center and pointing out towards the left, a distance of 64, right? We know we're going to the left because it's negative. This gives us an idea of what our angle should be. Our angle should be, in terms of radians, it should be pi. So another way that I could write z cubed equals negative 3 is to write it as z cubed equals 64, and then I could do like I pi, right? In the sense that it's now in terms of this angle pi, and it's got a length of 64. And then what this would allow us to do is to use our de Moivre's theorem, right? And de Moivre's theorem says when I cube something, when I square a complex value or I cube a complex value, I am multiplying the argument, the length, by 3, and I am, I'm raising the length to a power of 3, and then I'm going to multiply the angle by 3. And we can reverse this, right? So if we're looking for roots, we're going to divide these values, and we're going to take a cube root, right? So I could look at my first root. If I take a cube root of 64, that's going to be 4, and then we would have pi over 3. Or you could write it as 4 cis pi over 3. But we would have basically on our Argand diagram a much smaller value, a length of like here, 4, and it would only come out to pi over 3, like that. But this is just one of our roots. So if we want our other 3 roots, we're going to need to look for other solutions within one 2 pi circle of this start point. So if we do that, we want to find our other 2 angles, right? So if we're starting with pi over 3, we're always going to look at trying to increase our value by our range, which is our 2 pi. So it's going to be like 2 pi k. So if we went up by one value, that's going to be 3 pi over 3. That's going to give us a solution at pi, e pi, 4e to the pi. So we're going to have a solution here. Again, is shorter, and this time also at pi. And then the next one, we would do the same thing, right? So we're going to do pi plus 4 pi over 3. So this becomes 4e to the I 5 pi over 3. And these are our 3 roots, and I've represented them on our Argand diagram as well. Modulus argument form, so we've got our modulus, which is 4 in every case. That is the cube root of 64. And we've got our argument, which is pi over 3, but also repeated on our period for angles, right? So repeating on a 2 pi rotation to get the other 3, all 3 solutions that occur within this one circle. We're then told that the roots will be represented by the vertices of a triangle in the Argand diagram, right? So we're taking this picture. I'm just going to move. We've got our next problem sneaking out here. I'm going to move that down a little bit. I'm going to zoom in basically on what we've got drawn here, right? So Argand diagram again. I'm going to make this a bit bigger, and we're going to be able to see our 3 values, right? So this is going to be a length of 4. This is pi over 3. We're also going to have one that's here, and we're going to have one that's here, and this would be pi over 3 as well, but it's going to be like minus pi over 3 because we're coming down clockwise. So how do we get a solution to this? It says the roots are represented by the vertices of a triangle in an Argand diagram. And we're trying to find the area of this triangle. So the triangle would be shaped like this. a triangle formed by our three roots. If we're trying to find the area, there's sort of different approaches we could take. I think a lot of people try to maybe split it in half down the middle and try and find basically the area of two halves using like base and height. You can do that. I think the simplest way to do this is to think about it as three triangles, where each triangle is one of these shapes inside the Argand diagram. So each of those triangles, I can use my sine rule, basically, for finding the area. Because we can go 1/2, each side is 4, right? Because we've got, for each of those triangles, we've got 4, 4. And then we should know what the angle is going to be, right? Because it's pi over 3 plus pi over 3. So we've got a sort of 2 pi over 3 angle. And so we can put in sine 2 pi over 3. And that will give us basically our solution for what we're going to have here as our value. So we're going to have over 2. Yeah. So this is 1 over 2, 4, 4, root 3 over 2. And then this would simplify. 1/2 times 4 is 2. 2 times 4 is 8. So we've got like 8 root 3, but then we've got it over the 2, right? So it becomes each triangle is 4 root 3, and then hopefully there are 3 of them. So if we do 3 times 4 root 3, we get 12 root 3, which is what they are looking for the area of the entire shape. So the key thing here is once we can get, certainly at the beginning, once we can get our complex number expressed in terms of modulus and argument, it's then fairly easy using de Moivre's theorem to find the other roots. If we're taking a cube root, we are going to divide the angle by 3, and we are going to reduce 64 by a cube root, and that's going to give us one solution. We need to then find other solutions, and then we can come down and solve this area problem. So hopefully this is helpful. I did go through it a bit quickly, but there will be other problems as well on complex numbers that I'm going to put up today. So you should be able to find those on a playlist on the YouTube channel. So if this was helpful, or if you want to see more complex number problems, you can go and check those out.